Good morning, everyone, from me as well. We start the workshop with Apache Wayang, and I will show you how we have created a big data theater. So, it's fine. In 2012, that was the landscape of big data systems. So we had a few choices, and mainly we had Hadoop that everybody was actually using. In 2007, this picture grew up a lot, and here is the landscape with all the available platforms. And today we have something like this that is really scary. You can imagine all the choices that a developer or someone that wants to perform big data analytics has to do. On the other side, so this was like the systems that are available. In 2010, most big data analytics was based on relational data or tabular data and SPJ queries with simple like SQL queries and so on. But today, most analytics. Yes? Okay. I was saying that some years back, our big data analytics were very simple with just tabular data and SPJ queries. But today we have a variety of different data structures that usually we want to combine, and we have big data applications that are not only SPJ queries, but we have now machine learning, we have pattern mining, clustering, and so on. And now companies or users, they really want to combine everything in one application. So as you can imagine where I'm going, so before we had just Hadoop and we were writing MapReduce jobs, but now we have all this ecosystem and we really need to use more than one system to really apply, to really run our application. So now developers are left with the question, okay, so which system should I use for my application? And this is where Apache Wayang comes to help the user. So here is I will talk about what is Wayang, the history, the meaning of the name, and the goal. I will describe briefly the architecture of Wayang, and then Bertie Rodrigo remotely will go through the hands-on examples and how one can really code in Apache Wayang. So let's move on what is Apache Wayang. So slide 11. So yes, the goal is to decouple applications from the underlying platform. So the user focuses only on its application, and the system itself takes care of where the application has to run or is able to run. And we built a system called RIM, slide 12, and RIM, some of you may have already heard. We had some publications in VLDB in database conferences, slide 13. So there you can find more details, technical details or experimental results if someone is interested. So in slide 14, I want to mention that in the late 2020, RIM joined the Apache community and is now in the incubator program. And there you can find the link to the website where you can find more information. So what does it mean, Wayang? To give you a bit of, let's say, why we chose this name. So Wayang is a traditional form of puppet theater play that originated in the island of Java in Indonesia. And we chose this name because if you see in slide 16, we assume that the developer is like the director of the theater play, and Wayang is the infrastructure where it coordinates the puppets, where puppets are the actually the platforms and how they can coordinate and work together to execute the query that the user developed. So in slide 17, we have an example of how Apache Wayang actually takes as what is the input and what is the goal. So on the left side in the blue plan, you can see abstract operators like map, sample, and this is the plan. This is the Wayang plan of SGD, the stochastic gradient descent algorithm that we very commonly use in machine learning. And these are like standard operators that you will find in Spark and Flink and other data flow systems. And then here we don't specify on the blue part of the on the blue plan, let's say, we don't specify where each operator will be executed. And if you go on the right side, that is the orange and green plan, this is what we call execution plan. So Wayang will actually, using an optimizer, will actually determine each operator in which platform has to be executed. For example, here, the orange operators are Spark operators and the green operators are Java operators. And this is what Apache Wayang is able to do. So if we move on to the architecture of Apache Wayang and how it works, in slide 19, we can see it takes as input a Wayang query, which is like the blue plan that I showed you before, or some other in some other API that we have. Then the cross-platform optimizer will take the query and using some cost model and the cost learner will determine where each operator has to run. And then if you check in number two of this figure, some parts of the plan will be executed in Spark, some other will be executed in Java, depending on what are the platforms that the system supports at that time. And the executor is responsible to really take the subplans and execute them on the correct platform using some driver that our system contains. While the system executes the plans, the monitor, which if you follow is number 4, will monitor the progress of the execution and will keep some statistics in case some cardinality estimates, for example, have gone wrong. Then the progressive optimizer is able to actually re-execute or re-optimize, let's say not re-optimize the plan and execute it next time in a better fashion. So now I will switch to Bertie and Rodrigo, and he will show us the hands-on demo.
Okay.
Yes?
Thank you, Zoe.
Thank you, guys. Now we will, you have the...
Yes, hi everyone. My name is Bertie, the gray t-shirt, and Rodrigo is the purple t-shirt. And we are kind of the two main developers on Wayang. And now we will show you the how to preset up everything for the Hello World examples. Okay. We prepare some Jupyter notebooks. Could you see the letter, or do I increase the size? That is okay for you guys? Okay. This tutorial will be available in the GitHub repository of Wayang. There you can take it. But what is some tool that we will need here? One is Maven, the version 3 is the ideal one. The Java 8, and also you could use the Java 11. Okay, the GitHub version, any version is okay, and Docker version that it will be made required if you want to really use. And having Apache Spark and Apache Flink installed in a cluster or in your personal machine is okay. It will be really awesome, but it's not mandatory because then you can play with the standalone version. Okay, all the following code that you will see is running in a container that we prepare for you, that then when you download the code, you can compile and follow all of that. And here are the versions that are installed in on the container. But here is important things. Currently, you can go to the repository of Apache Wayang. Okay, and currently we are continuous developing many ideas, but there it is, and you can clone freedom. But this tutorial we will focus on the BOSS'21 tutorial that currently is not available, will be available after the demo. There you can play, contact us, send you an emails if you want something more. But there is the code if you want to have the code inside of your container. And here is where it start kind of the complex part. Compiling the code. As we use Maven, we use different profiles to help the life of the developer to don't be fighting if I am using Java 11, Java 8, because they have different dependencies, the same with the Scala and so on and so forth. And also if the system operating is different, all of that we provide some code that will be needed if that is your case. How we compile in this opportunity is with Java 11 and Scala 12 to just have a really the more updated ones. But as Java is retrocompatible, compatible, you can use also the version 8. It's not a problem to run. Okay. One thing that is important, normally this is just at this stage because we didn't do the first release yet in Apache, but we will do it soon. And there you can access directly for the Maven repository, and then you don't need to compile the code if you want to use the current version. But if you want to modify the code and play around, you will need to be playing with this command line so often. Okay, and also in this opportunity we use the skip test just to reduce the time, but if you will use in a production, we don't recommend it to skip it. No, okay, because something can get broken and so on and so forth. Okay, and Apache Wayang is really divided in different modules and components, and here we have the list. But as you can see, we have main three parts that are the core. That is where is the optimizer is located, where you can play with it, and also the basic, where is all the structure of platform and so on and so forth, the operator itself, they are. And also we have the Wayang API Scala. That is the API that we will be playing today because all the thing is with Scala. And also, if you see, we have Wayang Java, Wayang Spark, Flink, Giraffe, SQL3, Postgres. All of them, there are platforms that currently they are supporting by Apache Wayang. And the good thing is most of them, they run in both versions, except for GraphG because it's just having 2.11. Okay, and we have the Wayang profiler. That is the one that will help to get the data from your execution to enrich your cost function from historical data. Okay, there, I don't know if someone have any doubts until this point or do continues. Everything is okay. Oh, I think so. Yes. Also, we create a Jupyter environment that is the one that you are looking. And here we use the version Scala 2.12.12. But we don't recommend this. It's just for a good environment where you will have all the tools. But we really recommend to use IntelliJ because it will be more easy. But if you want to use this container, you will need to, after you clone, you will go to this path and then you can build your own image of the Docker. And this Docker is an extension of Almond SH. And you can use Almond SH if you already have. But what is the good things that we did? We installed some tools that also we will be using, like a Maven, Git, Netcat, that also we will use in this to help you in an easy way. Okay, but wherever you use, if you use Almond or our image, you will be giving this parameter. Okay, you will use the port 888, that is for running all of the container and all of the dependencies. Also, you will be giving access to the repository, to your folder of Maven, the Maven repository, to show the format locally to the Jupyter, because there we will see why we need this. And also the place where they are located, all of these Jupyter notebook that we are showing to you. Okay, one thing that we have is that the home user for these containers is home job work. Okay, but there is not something really relevant. Okay, but here is something really important. In our presentation and today, we are using 3 datasets. One is Laodicea. That is a book of 1 megabyte. You can download from this link, gutenberg.org. That is a kind of organization. And also we use the census of 90s of US. And also there is the link, and they use the Higgs particles dataset that is really famous. That is 7.5 gigabytes. Okay, you can get all of these files performing this command. We put it there. When you be there, you can download. If you see, we download using here, and there you will have all of them. Okay, and one thing that we want to alert you to, you don't get worried, because you will see many boilerplate in the next slide, sorry, in the next notebooks. But it's just because we need it because we are in the Jupyter environment and you don't have Maven or SVT or something like that. Then we need to do it like a kind of by hand. Okay, like I say, importing the code. We need this Maven local repository. That is the one that we already set up here. You remember the Maven local? Why? Because with that we can access to the code that you already compiled, that is in your local Maven. There, all the notebooks the notebook can access to that repository and consume your version of Apache Wayang. Okay, and how you import this module? We use Eevee that help you with that. One thing that is really important, you will see part of the code that appears 1 dot and another just 1. Okay, this is because with the 2 dots, you bring the Scala version that you are using. Because in our slide, in our notebooks, you have the option to pick a version 12 and version 11. We have two versions. Then for you code doesn't crash if you have the kernel, we do it in that way. Okay, that is how you set up. I don't know if you have any doubt. Here is just to clarify to you what you need. Okay. Now you will be with Rodrigo to do the hello world.
Hello. Now we will start with the examples. The first one that we will be dealing with is the word count example. Here, the first goal we have It's to understand how works the API of Wayang in a very short program, very easy, very simple to approach. And then we will see that it's very similar to the Spark API. Why have this been decided? To decrease the learning curve for new developers that are new or they already know a little bit of big data platforms. They can start working with Wayang in the most smooth way possible. Also, as a secondary goal, we will see that this platform Wayang, it's offering for us an abstraction on top of several big data platforms, as Zoe mentioned in the presentation. This is very important because a single data analytics task can run in any platform, and the user, will be only dealing with one way to define the logical plan. So he doesn't need to care about when and where it will be executed, the logical plan he's defining. Instead, he just can care about the problem itself, how to solve it. Also, something that is very nice about this is that potentially each subtask of these logical plans can be divided and run in different platforms and get all the advantage that could obtain from that. For example, running parallel and depend on every situation and use case that the user is presenting to the system. Let's begin now with the example. As you see here, and as Bertie said before, we need, in this case, to prepare the dependencies. We are using Corsair API to provide from the local repository all the Maven repositories, and we can get all the modules that we will be using in this example. This will be done in this step.
Yes, that is the step that takes most of the time, because you need to go to the local DBMS and do some tricks, but after that you can work without any problem.
Exactly. Now, as Bertie mentioned before, we need to import all the modules that we will be using in our code. In this case, we will be using already mentioned, Bertie mentioned part of them, but are the most basic modules that we need to use to work with Wayang. In this case, as he mentioned, we are using the API Scala Java, the basic that he already mentioned, and the core. Also, here we have the 3 platforms that we will be using in this example, but notice it that here we are only importing at the beginning the Java platform. Then, as we can see here, we need to, of course, include the classes that we will be working with. In this case, we have the Wayang API that it's giving us the operators and all the utilities that we are using to build the plan. And also here, for example, the Wayang context and the configuration that will help us to construct the plan and give all the information of the context where we will be executing it. Also, we're working with file system. It's an abstraction. If the user maybe want to retrieve the data from HTTPS or like in this case from the local file system. And the rest, what we already talked about. Yeah, as an input file, we're using the Odysea here, and it's a very small input source. The goal of this exercise is not check the performance. It's show you how the API will work and the capabilities it has. As we said, we are here working with the Wayang context. Wayang context is one of the central points of this platform, and is the entry point for users to start working with all the functionalities that Wayang provides to them. Allows also Wayang context to explicitly define what is the execution platform that the user requires to run the code. So in this sense, we are using here the Java basic plugin object to command to the system, to the context that you need to work with Java platforms. So after using it, it will enable the Wayang operators to work on the Java platform. It's important to mention that also the Wayang context is the one that is managing all of this, the creation and the execution of these Wayang plans. I think I didn't run this one.
No,
I'm sorry. Now, here the thing we are doing is commanding to the context to use the Java plugin. Yeah, now let's talk about the program itself. We are working with a work on program. As you can see here, the first thing you will notice is that we are working with a plan builder. The plan builder is just an utility that will allow us to work and build with Wayang plans. The Wayang plans have this shape and consist of a set of operators that have dependencies between them and are being under an optimization process by Wayang. And with that, it can transform this logical plan that you are seeing here in a set of physical operators that are executable, each of them in a specific platform that can be different for each of them. Yeah. Something important here that you can see is that with the plan builder, we are, of course, building this logical plan. And as you can see here, the API is very similar to the Spark one. Here we are dealing something to read the file, then we flag map to split the words. Then we filter the ones that are not empty. And with a map, we for each word, we assign number 1 to reduce and then sum the quantity of words that are equal. And then we collect them. As you can see here, this plan is totally independent of any platform. It's platform agnostic. So then we can see how this will work in different platforms. Let's run it. Now that we have our plan, we will pass to this function the context we already prepared. And if you remember, we assigned the Java basic plugin. Let's see how this works. Now, as you can see, the results were retrieved using Java. But then, for example, we can use a different model to do this. In this case, we want to use the Spark. So we need to instruct the Wayang context to use this target platform. We need to reassign the platform that we will be using. Here we need, of course, to get the dependencies that will be necessary, charge the class of the Wayang Spark, and then assign the plugin that we will use. In this case, will be the Spark basic plugin that allows the Wayang operators to work with Spark platform. Now we can run it, and as you see, with this very little change, now our example is working with Spark. And there is the results in Spark. Sorry. Here also, we can, of course, use also Flink. We will, again, include all the dependencies and set the plugin as Flink. And we can run it again with the new context that we generate. And this will be run in Flink. So let's be clear with this and how it could look the word count in any of these platforms. So if you see in the Java word count, the Flink implementation and the Spark implementation, they are super different. And the user need to really be thinking on the platform while writing the code. So this disaggregation that we propose from the API and the platform unleash not only this advantage that is only one code, unleash several very important capabilities that we will discuss in the next steps. Now we will go, to the second hello world example, let's say, and we will talk about the camins. The objectives of this second example is to show the capabilities that Wayang have to help the user to work with recursive algorithms. It provides several functionalities to deal with iterative programs, and with this, we will show how Wayang API allows the user to work with cycles. Also, it's important to mention that the enumerating process that has Wayang, it's of course taking care of allow this to happen, like checking if the operators were already processed and avoid experiment problems regarding that. And of course, we will review in a more mature example, a more realistic example, how to work with the Wayang API. Again, as Bertie mentioned, we need to prepare the dependencies in this case, but it's important to mention that after the field release, this will not be necessary. It's just for this example. So we will again prepare the dependencies And then we will be using another set of models to work with this second example. Now we will import the classes that are more or less the same than before, but of course now we are extending a function, implementing a function, sorry. And we have some Java and Scala utilities to work with this new code to show the Camins functionality. First of all, we will start working with some classes that, for example, will represent the points of we want to cluster in, and all the functionalities that we will need to deal with it. Also a target point when we are assigning to a centroid each point, and a counter to be aggregating these points that are in the centroid assignment. Then we have the aggregation functions and an average to the already aggregated points. Sorry, I don't know if I have been running this. Yeah, no, this one, of course, is selecting for each point, which is the centroid more close to them, and we're broadcasting the centroids to work with that. As you can see, it's a very simple and intuitive API that it's very similar to Spark or even Flink dataset. Now here we need to, of course, for the first iteration, select randomly the centroids. In this part, we can see the parameters that we are defining to work with this. Is the census information of US in the 90s that Bertie mentioned. It's 350 or 400 megabytes of data. We will work with 100 centroids, and the iterations we will work with will be 10. Now we will instrument Wayang to work with the Spark plugin.
One thing that is important to show in this case, and is that we are using a Spark, and if you know the Camins algorithms, the algorithms Camins have a loop, but the Spark doesn't support loops.
Yeah, that's important to mention. Thank you. Yeah, here in the Camins, we are again in the apply function. Set up the plugin that, as we saw, will be Spark, and then with the plan builder we pass that context, and then we build the plan that will be the Camins. We read the file, then we filter the empty lines, and here we can see that we are splitting each line to get the dimensions of each point, that is each line of the file. Now we randomly select the initial centroids, and we start with the loop to perform the Camins algorithm. As you can see here, it's very intuitive. The API, you just would repeat with the number of iterations that, if you remember, are 10, and we start with the loop. As you see, it's super simple to perform a loop here in Wayang. Then we are using for the algorithm the functions that we described before, and we get a result for the Camins, and we collect. So I don't think I need to see nothing. We can run it. So with this, we can run in a Spark the Camins algorithm in a very simple way that will help users to perform this kind of machine learning algorithms. There we have the results. Thank you very much for your attention. I will leave you with Bertie again, that will show more examples.
Yes, and Rodrigo mentioned, these are kind of the hello world examples, and one thing that is really important to have in mind is that we talk about, and so you also mentioned that we will be splitting, but we didn't show yet splitting a code. Just we show the capability of moving from one platform to another without modifying nothing, just giving a new context, giving a new plugin, and you can perform the query. But what happened and why we say that we are a cross-platform in Wayang is because the optimizer divide the task. And how you divide the task, it's how that process can be faster or slower in some context. Okay. In the example that Zoe mentioned before, that is the SGD plan, the thing is how you divide the plans, the performance that you will get will be different. Why? Because you will be affecting how these plans are performing. And even if Spark is the best platform for running in a huge data set, Flink is the best for running when you have a parallelizable task and so on and so forth, and they have them advantage. All of them have some weak point, and the idea is with Wayang detecting that weak points about using them cost model and to take advantage of that weak points. Okay, now we will see an I don't know if I can close this too. Now we will see how this looks. Okay, the opportunistic model, as we are mentioned before, we take a common API. We will go to that API because this already you know really well, and also that. And these are the kind of UDF that we have that we don't matter at this point, but are needed. Okay, and as you see, here is kind of in this area, the what is the real code. This code, as again, is the same that you see in the word count, the same that you see in the comments. But what is the difference? Okay, because I am creating UDF that are this one, that are the weight updates, that is the traditional SGD algorithm. How you can perform faster, how you can beat, and I will show first of all the Spark. Spark, here I enable the logs to see something. Oh, here there are the logs of Wayang that we didn't show before because it's just one platform. But here is how Apache Wayang is dividing the task in a sub-small task. And if you see, because in this case, our context is just Spark, you will be performing using the different operator of Apache Spark to perform the task. But how you are looping and so on and so forth, you need to do iterative this method because you know Apache Spark doesn't support loops, and also you will be broadcasting variable, which means that every time that you are executing something, it will get really slow over the time, because imagine in every iteration you need to you need to be performing the coordination between the broadcast and so on and so forth, because the SGD need to have a lot of coordination. And this was running locally, which means we don't have the overhead of the network, and take 48 seconds for the sample of the file that we have. Okay, that is a good time. I can wait 1 minute for performing the SGD. Why we say that the combining two platforms? Because now is something that we didn't see before. We are providing two platforms, which means now the spectrum and the number of combinations that you have are bigger. Okay. Okay. And as we did before, as we did before, we are showing the logs, and here is the splitting of Wayang does with two platforms. First of all, we take the collection source that is the first ones that are our initial weights. We can take the decision, the collections, we will do it just on Java because it's a small data set, it will be fine. But there, if you see, it say that the text file source, it will be coming using Spark, okay? And it will cache it. What does it mean that? Because if you know the code, the SGD, it's almost 7.5 gigabytes, and it's taking the code to be performed in Spark, which means it will be distributing that piece of code. One thing that is important here, that it is called map Java, not because it's performing in Java, it's because it's in a Java style, because Scala doesn't accept providing an object as a Lambda function. But here we need that, and we have that because it's something that comes from Java. That is why we call map Java. Okay, but doesn't mean that it's executed in Java. That is important because if you see this map, we call it transform. And if you see here, that map transform is performing in Spark. Okay, there is where you see, okay, now it's easy because you have a collection that is a couple of bytes and a file that is a gigabyte. Obviously, yeah, you will need to pick a Spark and you need to pick a Java on that way. But here is when the thing starts getting tricky, because you have the while. However, most of the person will say, no, I need to perform the while on Spark because there is all the data. But Wayang pick Java. Why? Because Apache Wayang take the decision just to perform the shuffle and picking a small sample using Spark, and don't perform nothing more of that plan on Spark. Just say Java. Why it does that? Because if you think in every iteration, you are taking a small sample of the data, but the sample that you are taking is from 7 gigabytes. There you need the horsepower that provides you Spark. But then doing the map, the reduce, the updating the weights and so on and so forth, computing the norm, is a really small data and you don't need a cluster for it. There, to don't perform that, Apache Wayang what does? Just say perform just the sample and read the file and transform it using Spark. Where you have the power, use it, but for the rest, it's really abusing, you don't need it. And even if it's counterintuitive to do that, we will see the results and it takes 34 seconds. And this time looks really close. 34 for Java and Spark and 48 for just Spark. But what is the reality? Because here we are using just one machine with too many memory RAM, where you can fit easily the file on main memory and forget about it practically. But as you can see here, this is a result that we already published in a paper where you can see that executing in a real environment where network you have, where you have bottlenecks and so on and so forth, where you need to coordinate several machines just to perform a small update in one machine is too much. However, when you go to the same context, you can reduce the time. And that is the important message here, because it is not about that what is the best platform to execute just one web. Wayang is searching in all the spectrum where and how take advantage of every platform and take the weakness of every platform to perform a better job, okay? Now, how we do that? How the platforms work on Wayang? Okay, it's a kind of really simple elements. We have the drivers, that is the one that is connected to the optimizer. We have the Wayang platform, that is an abstraction that allows us to plug anything that we want. We have some platform context, that is the one, for example, in the case of Spark, help us to say, oh, what is the Spark context? What are the variables? Where is the cluster? How many machines have that cluster, and so on and so forth. And also you have the platform executor, that is where you have the real code. And that code have two options, can be eager or can be lazy. And depending on that, because you know, if you have a filter, you will not perform immediately. It will be stored until you get something that really need to perform the query. And that is how this small architecture and really simple one can help to perform any platform. We didn't show database in this tutorial because it's almost the same. The unique that you do is taking data from the database, but we didn't consider because we want to show what is the real power of the optimizer and show how easy it is to programming in Wayang if you already know Spark, Flink, because as Rodrigo showed, the difference, even if it's huge, most of the case, the logic is the same. And even the UDF is the same. And that is the advantage that take Apache Wayang, okay? And as we explained before, the powerful of having this agnostic is not just to perform Apache query, because now the people ask, what is better, performing my query in a batch mode or in a streaming mode? I need a high throughput, low latency, and so on and so forth. And there are more questions that are coming. Then, do Wayang support stream? Not every, and when the RIM and Wayang start, didn't support streams, okay? And we were playing with this concept, and we figured out that if we treat all of the operator as a lazy, in the case of the streaming, and we save in a pool the threads, maybe we can do something. But what we can do, and we will show you right now. Okay, the stream here is just a small example. We have after we will show you something, but it's showing how straightforward for Wayang is supporting a platform that not necessarily they are Apache. Also, we can support streaming. But there, the question is, okay, what? Oh, wait. I will restart. Okay. The question is here. Sorry for it. Oh, wait, no. What is the important question here? That we want to answer if it's with small modifications, the stream are being able to be supported. Because if we are enabled to move from Spark to Java to Flink, why don't try with streams like a Apache stream or Flink streams or Kafka or whatever you want? Because in the end of the day, they are platform. And that is what we did here. We did a small piece of code, just implementing enough operators to perform a word count in a Spark stream. And this code, it is exactly the same than before. The unique difference is our input file now is an address. Okay. And why we can do this? And I will show you something that I want you can figure out what is the real powerful of all of this. Okay, we will execute this. just to start on a server. Okay, and this is the same code that was performing for Apache. Okay, and now if you know a little bit of the logs of Apache Spark, you will figure out that we are running a stream. Okay, but I will do something here to see if I will stop at this because it will be forever. Oh, bad movement. Let me, because I killed it before to be unable to. What is the thing? Is that without going to modify your code, just adding a new platform that this platform is a stream, we convert also Wayang not just in an agnostic platform that can run different bash engines, also that this same engine can perform string queries. There, as you, I don't know if someone know that this NC thing is in a just on a server where you can write and will be sending information to the consumer, that in this case is Apache Spark. And here you can see that it's consuming and performing the word count with the words that it's getting from the terminal. But if this is enough, oh, I think let me stop sharing to share my another screen. I can share, yes, here. Here is in a small video that we have of our platform running in a stream batch, sorry, in a stream way, and forecasting for energy consumption using exactly the same concepts, using Apache Spark, Apache Flink, and so on and so forth, but giving this performance because this query was executed in bash to figure out where are the errors, how the model is working, but also the same query can be performed in a stream to help to the persons to understand how really it works, how it moves, how it looks in a real time, the same query. This is the powerful that we want to show to you about how these tricky things that you can do with the platform can make Wayang really stable things. Okay. Now, coming back to the presentation, as you see, until here is how you switch from bash to stream, how you switch from different platforms, and how you combine different platforms to get the best of the best. But how we see Wayang in the future, where we want to arrive.
Yeah, one of the things we are working now is the Python API for Wayang. The objective of this is to incorporate a new API where the user can instrument their pipelines or whatever code they want using Python. And then any logical operator that they incorporate in their plans can be executed in any of the support the underlying platforms. We also, this of course being the underlying platforms, but we also want to incorporate new platforms that are based native on Python. So if they don't want to get out of Python, they also have the opportunity to use Wayang and execute the workloads there. The challenges working with this have been, of course, that the UDF, it's not like the other ones. These one are written in Python. For we're solving this, we're working in a very similar way to PySpark, where we are running Python in the workers, so they can manage everything in the same workers. In what another challenge we're experimenting now is that some cases like transitions between platforms are experimenting some performance issues. Now we are dealing with this one by one, and that's one of the things we are working now.
Yes, and the main goal of this is not just to say, we can execute Wayang in a Python or in a Java world. It's also to, that is the challenging part, to create a code that is enabled to run everywhere, not just Spark, not just Flink, whatever you want. Like, for example, running a Python in a Kafka using a stream processing, something that currently you can do it, it's tricky, but you can do it. But we want to make it smoothly for the person. Yes. We want to the developer feel like nothing, everything is transparent to them. Why? But when you do that, you will find really huge issue. Something that I was running in my local machine was running, but when I move to the big data, crash and crash again and crash again. There also we are working to implement a debugger on Wayang to perform a debugger in any of these platforms. It's an abstraction that helps to the person to perform with a really small overhead the debugging task using Wayang. And that kind of are the two main focus, also to continuous enriching the streaming processing. And that is the future of Wayang, how we see that we are moving, where we want to go. And I don't know if you have any question, if you want to add some comments.
Okay, great. Thank you, Rodrigo, Bertie, and Zoe, who had to leave. So questions at this point? Okay, in the meantime, yes, I have a question. Okay, I cannot see you here. So yes, basically you start presenting what you call the hello world, where the developer was specifying the platform, basically either Java or Spark, or in some cases you even use Flink. My question is the developer always on charge of this? So the developer has to say which platform to use, and the split, when you present also some splitting, do you have to specify something to the optimizer, or how it works?
Yes. Currently, if you don't want to take care and give the decision to Wayang, you can do it. You give all of the proximal platform, and Wayang will pick what is the best fit into your input file and your query. One thing that you need to be aware is that you need to be providing the cost optimizing function. That currently you need to use the profiler to like a kind of tuning by yourself for your cluster and your machines. However, we are working to we have one paper that is about how to perform doing a machine learning process, but that is not already integrated in the code that will be released in Wayang. But we hope in the couple of months that code will be integrating to helping you to really take the decision without you do nothing. But currently you need to provide the cost model.
Okay, got it. Thank you. And there is another question from Milad Rezai, that if you can explain again what the Wayang worker is in the previous figure you present. So it was kind of like an yes.
Yes.
What the Wayang worker is doing.
Okay, the Wayang workers are the nodes that are being used by Wayang to perform the the execution in the underlying platform. In this case, it's important because, for example, if Spark is running it, that subtask, to be able to work with Python, of course, the Wayang worker also it's running in parallel a Python task that is retrieving the results.
Yes, and one important thing is that, for example, because if you imagine in the case of a Java Stream and Apache Spark, they work in a different way. One is a centralized machine and another in a distributed manner. And the Wayang worker is the one that hire, we will say, the Python environment, run the Python code, and be sure that the Python code ended to return the control to the original platform.
Yes.
Because that is the tricky part. Yes.
Okay, Milad, you have your hands raised.
Yeah, I actually had another question as well. So I'm finding best platform for running a workload. I think it depends on hardware characteristics and number of servers you have and stuff like that. Do you consider this in finding the best data platform, how you tackle this problem?
Yes, currently in the optimizer, I show you a little bit of how we do it. Let me change to the idea. Could you see the code? Yes.
Yeah.
Yes. Currently, we are taking in consideration that variables. They are part of the platform itself. Yes, here in the case of the executor, in the moment that you will be executing, we ask to the platform if they have the configuration, for example, how many cores have every executor, how many machines you have, how many cores per machine you are available. In the case of Apache Spark, in the case of Apache Flink, it's the same. But there, for example, some platform like the stream, how many throughput, how many network you have, and all of that variable are considered in the cost model. But the unit that we are kind of in a lag is you need to tuning by yourself for your infrastructure, like providing all of these variables. And the idea is using machine learning or using some techniques to being able to retrieve that information automatically to enable to the system, to Wayang, to know all the variables or to know the most variable without you do nothing. That is kind of what we want to achieve. But currently we are focusing on have enough platform and have enough infrastructure to be getting running in different environment to get more data. And because with more data, we can tune and perform a better machine learning models to be able to really execute well the cost optimizer.
Thank you.
There is also one question from here, from the room.
So I don't know where I should look, but hello. So my question is, if I understand correctly, you can take live decisions and decide that, I don't know, at a certain point, it's better to stop using Spark and start using Flink for a streaming application. What are your plans? Can you elaborate? I mean, what do you do with the state that is currently in system A and that you don't have in system B when you decide to switch from one system to the other? So in terms of correctness of the results or guarantees about the correctness, if you can elaborate on that. Thanks.
Yes. I don't know if we have it show, but I think we have it. Yes, here. Something that we didn't mention is that when we connect one operator to another, we use some abstraction that we call channel. This channel is the one that is taking care about how move data from the platform A to B, but it's more like a sink and source operator to be really enabled to don't care if I am sending data from, for example, from Postgres, that I need a JDBC connector, to, I don't know, to Kafka, that you need to have another thing, or if Kafka is getting data and is getting in some format, you don't need to take care about the next platform. Why? Because the platform, one platform will have know how they can store the data on some place, for example, this, main memory, whatever. And another platform will have the source that will be enabled to consume that, that input. And that is the way that we are connecting different platforms. Currently, we are not merging batch and stream. It's just or it's full stream or it's full batch. But in the case of the batch, we can perform different kind of operation because the platform, they have the conversion operator to some common one. For example, in the case of the HDD, when we convert from the sample to the map, we use one collection channel because Spark can output you a collection, and there the rest of the step is just an stream processing, and you get back and again with a loop and so on and so forth. But that is kind of how we are dealing currently. Is the channel operator that do all of that work.
So extended a bit to that question. So and your answer. So basically, the developer has to make explicit if it is managing some state. For example, here in this example, in the orange boxes, right? I mean, for example, inside the map function, if you are keeping track of some counters or some local variables, and those variables are being used by the downstream operators, like let's say in the green boxes. So the developer will have to explicitly say to sync that variable so that the data can be transferred through the channel. Is that the case?
Yeah, yes, exactly. That is the case. You need to, if you are using a variable, you need to sync it to tell to the next platform that you need to consume or you need to use that variable. That is how currently we are solving that problem. But we know that maybe it's not the best. We are trying to find how we can deal it and doing that in a better way. But currently, that is the way that we are doing it.
Okay, thank you. Yes, there is one more question from the audience here.
Hi there. My name is Julian Hyde. When you call the in the API, when you call functions like flat map and reduce, you're passing in, it seems to me, lambdas, which I thought are Java objects or Scala objects. So how can you make that? How can you generate a cross-platform plan like executing on Postgres when the argument to that function is a Java object?
Yes, there. Yes, it makes a lot of sense. Currently, what we have is some lag about it, because, for example, when you perform a query, the database requires an SQL query. However, we have some operators that accept a string kind of operations, like, for example, when you want to perform some query in the database. But what we want to, and also we have some extension of PIC Latin. I don't know if you know PIC. We have some extension of it to try to achieve there, where the query can be translated to kind of code to a proper SQL, but it's really in Pampers. We can tell that we developed because it have many bugs and we didn't want to use yet. but also we have some SQL API that where you write your full query with SQL, where you really can place part of the code in a database engine and part of the code in a Spark because you can translate it and so on and so forth. But yes, if you are using UDF, unfortunately, we cannot transform that UDF to a SQL currently, but it's something that we know that is a lack that we don't have. But in the another way around, if you give us the queries, yes, we can perform in a different platforms.
Right, thank you for the answer.
You're welcome.
So do we have more questions here on the room? Let me check virtually for our remote participants. Do you have any question? That's fine. Okay, great. So let's thank the speakers. Thank you very much.